Welcome everybody. Today we begin a focused and insightful discussion on a subject that plays a critical role in our industry. This lecture will guide you through essential concept and the practical application and the real world challenges related to the fixed bid evaluation by discussing the idea related to the concept of weight average bid temperature. What is the weight average bed temperature? The weight average bed temperature represents the overall effective temperature acting on the catalyst bed used in the hydrocracking unit, in the hydrotreating unit, hydroprocessing, okay, and the reforming reactors in the first part of the hydrogen production plant, more accurate than when you calculate inlet and outlet temperature delta T, okay. Here in this reactor, we remark that there is a difference between the volume and weight of part A and part C and part B. Is it clear for all that part C weight and the volume is more than part A? And for sure the effect of the temperature difference for this part of the layer A and B will be different, so you cannot make direct summation when you calculate the weight average bed temperature. I want to clear that the effect of the difference in volume for each part is not equal, because part A smaller than part B, smaller than part C, as you see. And part C, the average temperature is 400 degrees C. For part A, which is smaller, it is 385. The effect of this one for sure will be larger when you make the final calculation. Why the weight average bed temperature is important? Monitor the catalyst activity and determine the reaction severity. The catalyst vendor specify this limit on the weight average bed temperature for each catalyst bed to determine the run length for the catalyst. You want to specify when this catalyst activity already consumed and you are at the end of run stage. Key indicator of a reactor performance for sure. Temperature profile in fixed bed reactor. Temperature rise with the exothermity through the bed, so you have inlet, increase in the temperature, and the outlet. The weight average bed temperature summarize the whole profile in a single representative number by this equation and ensure safe operation and prevent the thermal runaway. Okay. If we consider this simple equation and take the inlet temperature plus the outlet and divided by 2, for sure this will not be correct. Why? Because this will not represent what happened inside the catalyst bed itself related to each volume of each layer, okay? So if you calculate it like this, it will not be a true or real representative, okay? So the real equation is summation of the Ti multiplied by each weight. Then you divide this summation by the summation of weight, you will get the average weight bed temperature, okay? As we can see here in this chart and this drawing, okay, T4 and T1, for sure there is a big difference between the effect of this volume or weight and this volume or weight on the overall evaluation of this bed for this reactor. Here I have a larger volume, I have a larger weight, and the effect of T4 for sure will be greater, okay? For this numerical example, we have a top temperature 350 degrees C, middle temperature 380, and the bottom temperature for the bottom layer 400 degrees C. What is the weight? The weight mentioned here for each layer. So we need to get the summation. You multiply the first one, multiply the second and third, then you divide it by the summation of the overall weight of the catalyst. You will get the weight average bed temperature simply, which is 381, okay? I think it's clear. Why the weight average bed temperature increase over time? When the catalyst pass long time in service, you will remark that there is an increase in the weight average bed temperature. Why? Because for sure there is a catalyst deactivation and some coke formation, poisoning from the metals and the nitrogen and the sulfur exposure, feed contaminants increase and higher delta T from startup and shutdown and whatever. Loss of the accurate hydrogen partial pressure can cause increase of the weight average bed temperature through the time. The maximum allowable weight average bed temperature for each type of catalyst specified by the vendor or licensor. Okay, and if you exceed the limit, this may cause some harmful like excessive cracking or high coke formation, maybe thermal runaway or catalyst centering, and a higher reactor delta T alarm. Okay, operational and the operation team use the weight average bed temperature to adjust the reactor inlet temperature and maintain safe exothermity through this bed, control the state of run versus the start of run versus the end of run for this catalyst bed, and predict the cycle. How many years, how many months, how many days still the catalyst active. Okay, this what we mean by predict the cycle end. Compare reactor performance across run. The final conclusion here is the weight average bed temperature is the most critical temperature indicator related to the fixed bed reactor. Determine the catalyst lifetime and severity stability essential for the hydroprocessing unit, hydrocracking unit, okay, whatever the fixed bed, okay, catalyst and reactor. Accurate weight average bed temperature equal to safe operation, efficient operation, and reliable operation also.